All right. So this is objective 7.2, not A, but B. Remember, you did A already, so I'm going to change that to B. I'm asleep. 7.2B. Today's topic is angles of elevation and depression, and I'll wait until you're done. So your essential questions: can you describe angles of elevation and depression? And can you use right triangle trig to solve problems involving angles of elevation and depression? Okay, so let me tell you a story of a green-eyed girl and a blue-eyed boy. He's at home, that guy, in high school. Okay, and I'm going to use angles of depression and elevation to explain it. So I'm going to be the green-eyed girl down here. Let me zoom in just a little. Okay, so I'm going to be the green-eyed girl down here. And I'm going to be looking up at this blue-eyed fella on the second floor of the building. So he's going to be up here. And he's going to be looking down at me. Okay, so we've caught each other's eyes. You know what that means, right?
Children?
No, we've caught each other's eye. We've noticed each other. Hello? Okay, so what's happening between us is called a line of sight. Okay, so angles of, I had to elevate my eyes to see the blue-eyed boy. He had to depress his eyes to see me. So in order to have an angle of elevation or an angle of depression, I actually need an angle. The angle includes the line of sight, and then it requires the other side of the angle. And that line is going to be a horizontal. So I look forward, I'm looking at my friends, and hey, check out that guy up there on the second floor. I look up. My eyes pass through an angle of elevation. So an angle of elevation is the horizontal and then the line of sight above the horizontal. So this is the angle of elevation. So really important that we're talking about a horizontal and a diagonal here, okay? Now, an angle of depression, I saw him, he saw me, my eyes went through an angle of elevation, his eyes go through an angle of depression, okay? So this is also a horizontal and the line of sight. And what's interesting here, so this is your angle of depression, is that our eyes had to move exactly the same measure. They had to go through the same angle change so that we saw each other. So, in one problem, an angle of depression, if they're in the same problem, will be equal to the angle of elevation. Because you always have to think about the line of sight. It's the line of sight and the horizontal. These are the sides of an angle that make your angle of elevation or depression. So let's write our definition for angle of elevation real quick. So it goes like this. The angle, if you don't mind, I'm just going to draw an angle symbol between the horizontal and the line of sight. And from now on, I'm just going to label that LOS. Okay, line of sight, get it? Above, elevated, above the horizontal. So the eyes have to travel up above the horizontal. Notice I'm never mentioning the vertical. Okay, angle of depression. Pass your quiz this week. You will have to definitely know these things. Okay, angle of depression, I bet you can tell me the definition. the angle between the horizontal and the line of sight below the horizontal. All right. And again, if from each position above or below, it's the same line of sight, then the angle of elevation is exactly the same measure as the angle of depression. Okay, and that's true because if you're looking at these two parallel lines, these horizontals, pretend I did a good job. Now I'm marking them so that they are horizontal, they're parallel. That little mark that I made says they're parallel. Okay, these angles that are interior here in my letter Z, they're congruent. Okay, so I'm going to mark them as congruent. Okay, so they're congruent. Same side. That's just a rule. Alternate interior angles are congruent. Truth. Between parallel lines. So if you can make a letter Z with it, also you can do a backward Z, by the way. Angle of depression, angle of elevation, they're the same. Now what you're going to do, now that you know that, is you'll be dropping in a vertical to make a right angles, and then you'll use your right triangle trig to help you solve for whatever you're looking for. Okay, you got that? Yeah. So you're going to connect your angles of elevation or your angle of depression with a vertical, get your right angle in there, and then you can use SOHCAHTOA. Okay, so here we go. Let's skip to example 6 first because it's the less complex. It's the least complex of all the problems. I don't know why my text did them in an order like that, but that's okay. So let's do this one first, and I'll go ahead and read it since we're making a video so we can hear it, and then we'll draw a picture. Okay, so example 6, height of a bamboo plant. Also, this is a typo on girths. It should just say girth. Bamboo is the fastest growing land plant in the world and is becoming a popular wood for hardwood flooring. It can grow up to 46 inches per day. That's almost 4 feet. And reaches a maximum height and girth in this one season of growth. Girth is just how big around it is. Okay? To estimate the height of a bamboo shoot, a farmer walks off 27 feet from the base of the plant and estimates the angle of elevation to be to the top of the shoot to be 70 degrees. What's the approximate height of the bamboo shoot? So let's draw a picture. So let's go back. It says to estimate the height of a bamboo shoot, a farmer walks off 27 feet from the base of the plant. So I'm going to draw a bamboo shoot. They're usually kind of green. Yeah, you know, they have little limbs with little leaves growing off of them and doing all this stuff. And I think panda bears like bamboo. Okay. Anyways, okay, so there's my bamboo shoot. And what I want to know is how high is it? What's its height, right? I think you could probably do this without me. I do not want to insult you, but I'm teaching the lesson on the video, so go with it. So what does it look like if the farmer's walking off 27 feet from the base of the plant? Horizontal, 27 feet. You with me? And if he's walking it off, you know that just means he's putting one foot right in front of the other and he's counting to 27 because his foot's probably about a foot long, like that. Okay, so we got that taken care of. Now estimates the angle of elevation. So his eyes are down here and he's looking up, right, to the top of the chute. So we need the horizontal. We got it. Top of the chute would be over here. Pretend I did a good job. If I had my iPad, that'd be straight. 70 degrees. That's pretty basic. Okay. So, what do you think? What should I use? What trig should I use? Let me put my right angle in here. Okay, so now I have enough, right? Because I have the right angle, I have a side, and I have another angle, so I can solve it. So tangent, because we are looking for opposite and we have adjacent. So we go tangent of 70 equals 27. No. How about we do x over 27? Because we want opposite over adjacent. So x over 27. Clear the fraction by multiplying both sides times 27. Cancel. You get x is approximately. Go to the nearest tenth, please. 74.2. Let's get Confirmation, 74.2, and this is in feet. So it's interesting that it's just a bamboo shoot, and it's already over 7 stories tall. I wonder how tall they get. I'm interested. I'll Google it later. Okay, so there you go. A little simple problem with angle of elevation. Now, let's go back to this problem. Number 5. And it's actually true. Some kid in 4th period looked this up and saw the pictures and everything. So example 5, the gondola aerial lift. So in Telluride, Colorado, there's a free gondola ride that provides a spectacular view of the town and the surrounding mountains. The gondolas that begin in the town at an elevation of 8,725 feet travel 5,750 feet up to it doesn't say up, but I'm saying up to Station St. Sophia, whose altitude is 10,550 feet. They then continue 3,913 feet to Mountain Village, whose elevation is 9,500 feet. Okay, so this problem gets a little confusing because we're working on angles of elevation, and now these towns have elevations. So that's different meaning. And then one of them has an altitude instead of an elevation. But if you look at, so right, Station St. Sophia has an altitude of 10,550 feet. But if you look at the picture down here, it says it has an elevation. Because altitude, elevation, same thing. Okay, so when you're driving up through the mountains, do you ever see those signs that say reaching an elevation of 6,500 feet or whatever? You know what that means? That you're above sea level. Sea level is 0 elevation, so you're this high above the sea. And Yuma, we're below the sea level, I think, like 10. We're depressed. We're not elevated. Okay, so that's just sad. Okay, so let's just break this problem down. Notice it's nice that they gave us pictures to help us out. Okay, so we're supposed to A, find the angle of elevation from the town to Station St. Sophia, and then B, find the angle of depression from Station St. Sophia to Mountain Village. Okay, so thank goodness for pictures. Remember, we need measures. So let's take a look at the picture from the town to Station St. Sophia. We are looking for the angle of elevation. Yes? So I'm going to grab my black pen so we can see what we're doing here. Okay, so we're going to do problem part A. Here's what I know. We're traveling this distance, and it tells us we're going 5,750 feet, and we're looking for the angle of elevation. This is what we want to know. What is theta? That's a really good theta. There we go. Okay. And this is the town, and up here is Station St. Sophia. Okay, so I have one measure, two measures. If I drop in a vertical, I have a 90-degree angle and I have a side. Well, that's not enough information to use trig. So there's 2 more pieces of information I can use that will help find another side. Notice that the town has an elevation above sea level of 8,725. And then the Station St. Sophia has an elevation that's like almost 2,000 feet above that. So Station St. Sophia is up here at 10,550 feet. And the town down here is at an elevation of 8,725 feet. So there's a vertical distance between them of, what, 1,825? Check my math. Feet. Okay, so there we have the information that's going to allow us now to actually solve for theta. So what trig function? We're looking for theta. We have opposite. We have hypotenuse, OH. So we're going to use the sine of theta is equal to 1825 over 5750. Awesome. Solving for theta means inverse of sine. So we'll take sine inverse of both sides. And we get theta equals the sine inverse You're going to have to plug that into your calculator because I don't have it. Could you repeat that, John? Let's get confirmation. Okay, to the nearest tenth is good. 18.5 degrees. Beautiful. Okay, so there's problem A. So that could give you some really good indicators of how you would solve problem B, right? Now, problem B, the only difference is now you're starting at the top and you're working your way down. So sometimes it's really good to just flip that triangle over, right? So let's go down. I'm going to have to go down here to do some math here. So here's B, and we're starting up here at Station St. Sophia, and we're traveling, what was the distance again? 3,913 feet down to Mountain Village, which is down here, right? And then you have an angle of depression. That's what you're looking for, right? We're looking for angle beta. That's not a very good picture. But that's the visual that we have. True? Okay, so we need this distance right here again. I think I'll put this outside, 3913. You can leave it inside, doesn't matter. Okay, so again, we have these elevations in play. So we have a vertical distance. We're just going to have to do some subtraction to find it. So the distance from 9,500 feet elevation to 10,550, that's a difference of 1,050? Check my math. Feet. Okay, and so we're just working off of your angle of depression here, the horizontal, and then looking down. So we're looking for angle beta. So again, that's opposite and hypotenuse. And so we will use sine again. So sine theta this time equals 1050 over, that's not a 6, by the way, 3913. So inverse. So theta equals sine inverse of 1050 over 3913. And you're going to give me an approximation. Should be a little less, I think, of a degree. Let's get confirmation. 15.6 degrees. Okay, so I just want to mention something here. In this picture right here, we worked off of this top triangle, if you recall. We just did that. And this was your angle of depression, right? But if I want to, I can go ahead and drop my vertical distance this way, because your hypotenuse is still going to be 39. This is still a vertical distance, 10,050. And remember I told you it's these angles inside the Z? The angle of elevation is also, it's the same as the angle of depression. So if you'd rather, you can transfer all that information to the perspective of your angle of elevation, if you'd like. But this is just a rectangle, right? So these are the same, right? It's the same, right? Up to you. Okay, so having said that, any questions? Okay, then last problem. All right, now this one doesn't come with a picture. And although it's a lot shorter word problem, it's more complex to solve. So let's see if we can read it, and then let's unpack it and see what we can figure out. Distance between towns. From a hot air balloon 2 kilometers high, the angles of depression to 2 towns in line with the balloon. So they're in the same line. Okay, you can draw a straight line between the balloon to the town to the other town. Straight line. And the towns are on the same side of the balloon. And their angles of depression, I'm reading it again, are 81.2 degrees and 13.5 degrees. How far apart are the towns? Okay. Well, let's unpack that. We're trying to find the distance between the towns. I'm thinking that's probably a horizontal measure, okay? Because you got your balloon up in the air. So let's draw a picture of a balloon. Let's just put it over here in the sky. Okay, so here's a little balloon. Here he is, up in the sky. That's not a light bulb. It's a balloon. Okay, so there's the little basket. It's good. It's fine. And put some eyes in it because they're going to be looking down at the town. Okay? So how high is he? Vertical distance, 2 kilometers. Man, I don't like this. I'm going to get a line, and I'm actually going to draw a line because this is driving me bananas with my lines that are not good. Okay, that's better. Okay, so I'm going to try to do something that's fairly, and I'm also not going to do a dotted line. I'm going to do a full line. I'm going to do this one in blue. Okay, so I'm going to take my angle of depression. So that would be this line here, okay? The horizontal, and I'm going to depress my eyes 81.2 degrees. So tell me when I passed through. Let me see if I can if it'll let me move it. I'm going to pass it through 81.2 degrees. Let me know when you think I've gone 81.2 degrees down. Well, guys, I'm almost at 90 degrees. Okay, I'm good? Okay, so I'm going to go back and put my angle, my horizontal in there. So I'm going to put my horizontal in there. Got it? And I pass through an angle of depression of 81. Oh, let me do that in blue since we're doing everything else in blue. 81.2 degrees. And here's town number 1. Awesome. Now, I'm looking for horizontal distances, right? So maybe it would be good to turn that into a right triangle. Okay. So I'm going to stop, and we've just looked at that. Now, let's get the other town in here. Now, the other town, my eyes are still over here, but now I'm looking out further to see the other town, which is in the same line. So let me get another line here. This time I'll use pink. Oh, sorry, you guys don't have pink. Green. Okay, so here's my horizontal. Oh, wait, I'm not drawing lines. I forgot what I was doing. Let me get a line. Green. Okay, so here's my horizontal. Tell me when I've dropped my angle of depression 13.5 degrees. Oh, come on, let me have it. Come on. Oh, stupid thing. Let me try again. One more time. Stop. Horizontal, and I'm depressing. 13 degrees. Let me know. There? Okay, so let me extend that out a bit. Yeah? Well, I'm trying to draw something that's somewhat to scale. So you're thinking this is about 13 point, that's not a 3, 13.5 degrees. 13, that's a 3. Okay. And I'm looking again for a horizontal distance. So let me extend that guy. No, I'll draw a line. I keep wanting to draw. I forget that I'm not using my iPad. My iPad will make really pretty straight lines. Okay, I'm going to just connect those guys. Okay, so here's town 2. I know, they're far apart. Okay, so I'm going to come back over here now. And what I'm trying to figure out is how far apart are these 2 towns? That's what I'm trying to figure out. All right, so maybe you have suggestions. I'm going to drop in my right angle. And then I'm going to just pull out this little blue triangle here and see if I can tell myself some stuff about it. Okay, so here's town 1, and up here is my balloon. And this is 2 kilometers, and this is my right angle. I need one more piece of information in order to solve this right triangle. Can I use my angle of elevation instead of my angle of depression? Because if my eyes are down here and I'm looking up, am I not going 81.2 degrees? So I'm just going to transfer my 81.2 degrees to the angle of elevation. And now, can I find the distance from the base of the balloon to the town, which is a horizontal distance? For sure, right? So that's opposite and adjacent. So we'll use tan. Tangent of 81.2 equals opposite, which is 2 over adjacent x. We don't know. Oh, we should probably use y. It's okay. I'll just change this. Okay. So we're going to find that first distance. Ready? Solve for x. So we're going to multiply both sides times x and then divide. Yes? So we divide both sides by tangent. Basically, these two guys are going to switch spots, right? Could cost multiply, in fact. Okay, so x is equal to 2 over tangent 81.2. Give me an approximation to the nearest tenth. 0.3 kilometers. Okay, so this is that distance. I'm going to come up here and just write that. 0.3 kilometers. That's that distance right there. Got it. Okay, anybody have suggestions what I should do next? Remember what my goal is. My goal is just to find the distance between town 1 and town 2. Now, I know the distance from the base down here at the bottom, directly vertical underneath the balloon to town 1. Suggestions? What if I just solve this big right triangle and get the distance from the base here to this distance over here? And then subtract the two distances. What do you think about that? Then it's pretty much the same thing, right? So let's draw this picture. Okay. So here's my balloon. Here's our vertical distance, 2 kilometers. We want to use that. And then here's town 2. And there's multiple ways to solve this, by the way. If you've figured something else out, awesome, do it. What's this measure down here? My angle of elevation. Because up here, my angle of depression's 13.5. So we'll use 13.5 degrees. So now we're looking for, I'll make it y. Okay. So we're looking for this distance. So we do tan again. Tangent of 13.5 equals 2 over y. Multiply by y, right? Divide by tan. So y equals 2 over tangent 13.5. You get an approximate value. Go to the nearest tenth. 8.3 kilometers. So the whole distance, oh man, I'm going to have to draw this. It's kind of messy, but we're talking about this entire distance from here to here is 8.3 kilometers. So the distance between the towns, 8 kilometers. Did the lights just come on? I heard some light bulbs. Well, I heard them because I heard, oh, okay. So again, I'm going to go ahead and just stop the video so that everybody that's watching can move on to do the homework. So bye for now.